Good. So today I'm gonna take like a completely different directions because I think many of you are kind of like tired of all this like open science and applications and what do you want from us? We are not in judgment decision making or social psychology. We just want to publish in high top tier impact factor journals. So give us a break. Give us something we can use. So this is what we're here for. This is our session. This is where we're going to publish in Science and Nature. So today we're gonna go slightly to the side to talk about the most impactful direction out there that all of you can implement in whatever domain you're in. Don't have to be a social psychologist or a judgment decision-making person. Meta-analyses and systematic reviews. If I would be a student in your stage of the career, this is what I would gamble on for many, many reasons. So I will walk you through the meta-analysis direction. We'll talk about both on how to do this, how to approach this. Is it useful, not useful, for what kinds of things? And of course, because we can't completely ditch open science, we'll talk about some challenges and how we aim to overcome those. I will try as best I can to give you a demonstration and to also get you to, it wouldn't be like a hackathon with teams working independently, but I will give you like an exercise and we'll try to do a very short meta-analysis in Jamovi together. So it will be like a hands-on for you to see that meta-analyses are actually very, very simple and a very good tool for you to use in your research. Something for you to consider. Before I begin, how many of you know how to do a meta-analysis? Raise your hand. Yeah. How many of you have done like a project that led to either a preprint or a publication with meta-analysis? Some of you? Yeah, okay. 1, 2. Okay, good. May I ask what kind of meta-analysis was it? Like a correlational, experimental, what domain?
Correlation.
Correlational?
Personnel, traits,
and sleep. Terrific. Okay. And you were part of a big team, or is it like a big team? How big is a team?
Actually, mainly two authors, one PhD student and me.
Oh, okay. Not that big.
Yeah,
and then many other coders.
Yes.
Okay. How long did it take you to do the project?
2 years ago, I started.
Okay.
So far, we are still like.
Oh, still coding.
I think it has already been printed.
Okay.
But not published.
Oh, not published. Okay. How long was for the whole search in the code to do? So you had a research question.
Research question, yeah. Article reviewing, abstract,
Yeah.
1.5 years.
1.5 years. Okay, great. So now it's like under review somewhere?
Yes.
Okay. May I ask where?
That's next review.
Okay, yeah, that's a high target. Okay, terrific. Thanks for sharing. Do you want to tell us a little bit about yours? What is your project? Rumination inhibitory control. Okay, nice. This fMRI meta-analysis. Okay, wow. So is it like a correlational thing, or there's like more stuff going on there? It's mostly a correlation. Okay. In both of your meta-analysis, how many studies did you identify? Finally, how many effects do you have?
45.
45 articles or 45 effects?
45 articles.
Oh, 45 articles. Okay.
Yeah.
Okay, nice. And how about yours? Okay. So the correlations between them, how many studies overall? 25? All right. Interesting. So it seems like there's more experience here in this classroom than I imagined. So maybe you can help me out with some stuff. I'll tell you a little bit about my experience with things. But I also want to show you some research resources So it doesn't matter how many meta-analyses you've done, how much experience you have, you can always benefit from more resources. I have to admit, I've done a few meta-analyses and quite a few mini meta-analyses. I still don't know much about meta-analysis. I keep realizing how ignorant I am. So it really helps when you have a big team that keep inform one another. I'm also not a statistician. I don't know much about statistics. Anyway, in SIPS 2019, I think it was, a bunch of us got together and decided that we need one major resource. So another very long, big Google Doc that you can use, how to do meta-analysis. So if I'll just open this for a second. It still keeps on updating. So if you've done anything regarding meta-analysis, if you want to contribute to this more, I don't know why Google suddenly flagged this as suspicious. Don't listen to Google. This is like decent. So you can go on and have a look for a bunch of things. The most recent one, so this one, Matthew here, joined our team most recently. He is the person who is in charge of, if you aim for Psychological Bulletin, which is considered to be like one of the places that publishes meta-analysis and a little bit difficult, very difficult to get into. So him and his advisor is the Psychological Bulletin chief editor, and he is a PhD student working with Psychological Bulletin, and he is now responsible for reproducibility of meta-analysis. They both know a lot about meta-analysis. So Matthew is helping us with the effect size guide, power analysis guide. The guy really knows his stuff. So it's great that he's joined these. We have other people in our team. So Adrian, I'll talk a little bit about today, and some others who have helped make this a reality. So from articles to videos to how to do things about like search, coding, reproducibility, coding artifacts, estimating, all the things that I can't go over with you for months are in there. So whenever you hit a wall and you don't know something about a meta-analysis, this is the place where I go. And I recommend it also to you. There are also some advanced things, some Hong Kong people based in Singapore that used to be at HKU. So for example, a meta-analysis SCM, the person who did the package for that, and also collaborates with some of us. I think him and Singh work together on a bunch of things. So Bayesian meta-analysis, SCM meta-analysis, whatever it is that you're into, there's like a bunch of stuff in here that you should check out. So just know that this is a resource that's available to you. I'll first start with like, why should you care? And I think it's important to understand that as early career researchers, meta-analysis is the best strategy for you. And I remember 2017, the year I came back from Maastricht to Hong Kong. I gave a workshop at HKUST, which is my old school. And then HKU heard that I'm giving a workshop at HKUST, and like, why are you giving one there and you're not giving one here? And I said, yeah, I've never been to HKU, so invite me and I'll come. And I came in and I gave a workshop. And I remember giving this workshop. It was like a 3-4 hour thing. And I started with these slides. And I didn't know if anybody was listening, but turns out that a few students, PhD students at HKU, took this very seriously and started to just do only meta-analysis and got published quite well. Finally, I think one of them is got the presidential assistant professor at NTU in Singapore. Like some good students from HKU really decided to take this all the way. So glad that I could introduce some of that to them. Basically, I told them that 2017 was a difficult year for me because I was trying to deal with a lot of things to decide what I want to do with my research. Should I keep my old research or do something else? And I decided to do all the things that I talked to you about in the first session: trustworthiness, reproducibility, replicability. I care about all these things. And the question is how to tackle these so we can do replications and open science. But meta-analysis solves a lot of these issues. So you can see the yes, 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 yes next to all the different items. So meta-analysis really allows you to gain some simplicity. It's basically a main effect. So just like you heard here, we have a basic correlation. So to check correlation within a table in an article is generally very straightforward. We'll do this together in a bit. It focuses on effect size. So there's less of the p-value lower than 0.05. It's more about, so how large is the impact? Then there's all sorts of things that you can look into in terms of moderators and things that are meaningful to create theory. And it has a lot of power because if you've got fMRI studies that have maybe been done with a sample of 10, 20, 30 is amazing. Each one of them is underpowered, but if you take all of these together and you add them 25, 40 different samples, then they become a lot bigger and then you'll have more power. So you aggregate the power. So meta-analysis allows you to take other people's work, combine it together, and then reach the power that is required. I think the most interesting of those for early career researchers is that you always worry about whether you're going to get significant findings. Am I going to get the p-value lower than 0.05? Can I publish this? Yes or no? The good news about a meta-analysis is that you don't care. Whether you have an effect or you don't have an effect, findings are always good. Actually, it would be a really good thing to summarize a literature of 40 different articles and then to say, but actually, there is no effect there. We've been spending too much time on this. Perhaps we haven't been looking at moderators. So the good thing about a meta-analysis is that whatever it is that you find, if there is an effect, not effect, how large is the effect, all of it is interesting. And you can code all sorts of things in order to get additional insights. So a meta-analysis helps with all the issues that we're talking about. So benefits for a meta-analysis, a systematic review of the entire literature, is that it really offers you some insights, not from a specific study or a specific experiment, but looking at everything together as a whole, trying to get the insights of a lot of brilliant researchers that have published, worked hard for many, many years, and then give you a sense of what's happening in this literature. Do I want to build on this literature? So I suggest to all the students that are working with me, the very least start with a replication and a meta-analysis. So you're walking into personality traits and sleep. You want to understand what's happening there before you run into doing an actual study, spending many hours observing people in bed overnight, lots of sleepless hours. Instead of that, you just search the literature to see what people have done on this before. Whatever you do is valuable. And I think this is a point not appreciated by many students, is that it's very easy to conduct. I don't know how it was for these two projects. How did you feel about how difficult it was to actually do the code? How did you do the code? R?
Yeah.
R? Difficult? Senior students? Which package did you use? Do you remember?
Yeah.
Metaphor?
Yes.
Yeah. Yeah, that's the most common one. Pretty straightforward, right? In terms, especially if it's a correlation. You've got IV, you've got DV, you've got all the correlations, and then you summarize this. So I'll show you how to do this in Jamovi. I'll also demonstrate some things on how I did this with my collaborators back when things were not as simple. Finally, for early career researchers like you, why would you want to do a meta-analysis? Because you don't want to rely on your professors. You don't want to be dependent on the PIs to give you 200 participants, 50 participants, access to a scanner. You don't need them. You can do everything on your own. Just go read the literature, issue a call, get some unpublished research, aggregate everything together, and you've got a paper. So it's much easier than actually trying to get the money, the funding, the support from the PI. I know how difficult it is for students to get access to all these things. So no need for any of that. All the literature is out there. All the information is out there. You just need to go seek it. So simple, systematic process that doesn't require a lot of resources, very low risk. So whatever you find is actually interesting and publishable. And it's very, very much needed. So I don't know how much another study on personality traits and sleep is going to do beyond the 25 that are out there. But meta-analysis, if it hasn't been conducted, could be very valuable to give you the insights that you need. And I think in the first session, I was asking you which ones are the most citable, the ones that get the highest number of citations, and are mentioned. The first thing that you actually read when you do your own background search for your thesis is a meta-analysis or a systematic review. So that's a good place to start. I'll just tell you how I did this. It took me a while to understand that this is a valuable thing to do. So I finished my entire PhD without knowing anything about a meta-analysis. But then very randomly, I was trying to invite a scholar from the UK to visit HKUST because they told us as students, please reach out and bring people to Hong Kong. So I knew this, we both did stuff on values. I grew up at the Hebrew University in Jerusalem, so there's a big personal values group over there. So I knew this researcher, and I asked her, would you please come to Hong Kong? And she said, yeah, I would love to. She sent me her CV. I saw the CV. And I said lots of interesting things in there. And then I saw an unpublished preprint, a draft that had meta-analysis between personal traits and personal values. And I thought, this is really interesting. What is the link between personal traits and personal values? Are they the same? Are they different? I don't really know. I asked to look at the meta-analysis and the draft. And she said, no, we ditched this a couple of years ago. We don't have time for this. And I said, how about I help in? So this is my first time coming in, not knowing anything about the meta-analysis and offering to help. This has been by far the most cited work that I've ever done. I think it has now reached like 600 citations from 2015. So 1 year after, I think the only reason why I got my postdoc was because this was like in press. So this is the first project that I've ever done. And it was very straightforward to get this into like I've struggled with publishing a lot of things during my PhD, but this was, first we went to Psychological Bulletin. We got 5 reviewers, 2 for, 2 against, and 1 kind of like more work is needed. And then the editor said, no, we need a consensus of everybody agreeing that this is good. So we went to PSPR, and almost immediately it got published. So that was the most straightforward thing that I've ever had with these kinds of journals. Since then, in Maastricht University, I decided to do this with all my master's students. All of them finally got their meta-analysis published. So that's nice. And now we've got 3 registered reports, one of them in PCIRR. So this goes to show all of these are master students, PhD students, and me as a PhD. So all this is doable as a PhD student, just to show you what's possible if you want to. Another concept that I was not aware of during my PhD, which I hope you are, is a mini meta-analysis. So if you read the JPSP, for example, Journal of Personality and Social Psychology, not all of you are in social psychology, but for us, this is a big journal. I don't know why, but there's this obsession with having 8 studies, 10 studies in a single article, completely unsustainable, but this is the way that this journal works. And the question is, after 8 studies of the same kind of phenomenon with different effects, how do you know what to do with this? So let's say I follow up on a JPSP with 8 studies and I want to do a power analysis. What should I do? How do I decide what is the right effect? So I learned very late in the game about the possibility of doing a mini meta-analysis. And actually, after that, I've tried to include this in almost every article that I have that has more than 2 studies. So I've done this 2 in 2018 and then in 2021. So it's really like something very, very useful, and I'll show you how to do this. So we are not going to do a full meta-analysis, but I will show you how to do a mini meta-analysis. Okay? So I'll start with a demonstration. Some of you really like Jamovi, so I'm going to show you this with Jamovi. And I'm going to ask you actually to help me code. I've done this already. It's already published, but I'm going to ask for you to get your skills running on how to identify a correlation in an article. So in order to do this, I'll ask you to go on this link. It links to an article in a Dropbox. And this is the article that I published. I can't remember what year. And it's my most hated article from my PhD thesis. I did not want to do this project, but I was at the business school and they told me you have to have outcomes, work outcomes. And I said, okay, I'll do work outcomes. So it's the link between the belief in free will and job satisfaction. So they really wanted to see whether this links to that. So I'll just open this if all of you got the link. So it's mgto.org/6010 week 7. I'll open this and I'll show you what this is. After I'll walk you through this article, I'll show you how to do Jamovi in my other laptop. And then I'll ask you to try and do a mini meta-analysis of the 3 studies that I've done in this article. So we'll do this thing together. So this is what it's called, Agency Beliefs Over Time and Across Cultures. I tried to get a bunch of different data sets that were available to me and to summarize different correlations from different samples. So I had a Taiwanese professor at HKUST that was very good at collecting data with multiple waves. So you can see 252 Taiwanese real estate agents. We had wave period 1 and period 2. Then I thought I was clever back then when MTurk was just starting out. And I thought, if this is job satisfaction and MTurkers are actually workers, they're online workers, and what they do is participate in tasks for a living, I'll just ask them how satisfied they are with their MTurk work. So I thought it was a clever use of MTurk, actually studying MTurkers for what it is that they do instead of giving them stuff about surveys about other things. So I sampled them twice over a 6 period time, 6 months period time. And then study 3, I took an existing data set that is out there. All of you can use this. I think it's not utilized enough. World Value Survey. So, and then I coded country level moderators. So this is a good example of how, if you're being asked to do something that you don't want to do for your thesis, you just like get a bunch of data sets together, work cleverly, and then put it all together. So it seems almost like 3 separate studies, but now after this, we want to aggregate this into one message. So we've got this Taiwanese study, 252. We've got this American MTurk, 137. We've got this huge data set from the World Value Survey with 14,000 participants. What are the results here? What actually happened? So we want to try and find where the correlations are. So what you can see here is that we've got like study 1, we've got the means and the standard deviations, and then we've got the correlations table. So we need to extract this from that. This is study 1. Study 2 on Amazon Mechanical Turk, we need to do kind of like the same. So we'll need to find the correlation somewhere here. So here's another correlations table, and then we've got time 1, and then we've got time 2. And then finally, country levels, table 3 for study 3, we've got another correlation. And the question is how to aggregate all of these together. So you'll see that here at the end, after I had study 1, study 2, study 3, I just added another section called General Results, a mini meta-analysis, where I aggregated all of these together and somehow got to the conclusion that the overall correlation is 0.29 or 0.25 for time 2. So we'll try and validate this together. I'll ask you to punch it into Jamovi. I'll just show you how this works in Jamovi because it's very straightforward. So I'll just switch this. You've got a bunch of modules, so you can install. It's done. Yeah, you can install in Jamovi. You can go and add Major. This is what it's called. It's a meta-analysis for Jamovi. It's a very easy module. I know the guy who did this because before we had Jamovi and Major, I was actually using his Shiny app, which is absolutely amazing. I was trying to do my own Shiny app. So if we'll go and see his Shiny app, which is still there, it's called Mavis. So Mavis versus 113. I don't think he updated this since he started to do things with Jamovi, but his name is Kyle Hamilton, and he's also on the meta-analysis syllabus, and he's been working with us on a bunch of things. And the nice thing about this thing is that even if you don't have Jamovi and you just want to very quickly do a mini meta-analysis of a bunch of studies, you can actually use this Shiny app. So for example, if you've got somebody that doesn't want to use Jamovi and you just want to use this, you could. It does online a meta-analysis of either mean differences or correlations. So if you want to see the correlations, he gives a bunch of examples. So I'm just going to copy paste this from his examples. So you can go here, just put all the information there. So basically you got 4 columns: study, sample size, the correlation, and the moderator. And if you do update views after choosing correlation, you do update view, you see that it actually starts to render everything. So it just does all the meta-analysis for you. So if you've like searched and you've coded all of these studies, then this Shiny app will just create the meta-analysis for you. So you will convert everything to Fisher Z, run both fixed effects models and random effects models. We're not going to go into this too much right now, but basically it gives you the 2 types of meta-analysis that you can do with the estimated effect size. So in this case, it's 0.15. And then it also gives you the interesting plot that we've seen in other RR assessments. So you can see it just like gives you the effect size with the confidence interval. And if you remember how big the rectangle is at the beginning and how narrow or wide, the more narrow, the larger the sample. And with the big ones, the bigger rectangles represent a larger sample. So you can see at the end, there's this diamond over here that summarizes the effect size. So it does a forest plot, there's a funnel plot, so it puts everything together. It's just like the only thing that you need is just to put in the numbers and it will do this for you. So very useful. It might seem like something very easy and straightforward now, but I can tell you that in 2012, this was not to be taken for granted. Very difficult to do all these things. Plus, it introduced like a moderator analysis. So if you go here, you can see that there's a moderator column, whether this was self-reported or other. So it actually already does the moderator analysis for you with something pretty interesting. So when Kyle came out with this, I was just so grateful because I knew how painful it was to share this kind of thing with my collaborators. So this article that you're looking at, when I shared this with the Taiwanese professor and my advisor at SGUST, they're like, but we don't how to run this, like what can I do? So I needed to create stuff for them, and I didn't have this, and I didn't have Jamovi. So what I ended up doing, it was my first time trying to do a Shiny app. Yeah, so I was trying to create stuff for them, just so they'll be able. So for example, free will, beliefs, and job satisfaction, I was trying to create a Shiny app for them. I just want to show you how simple it is to create a Shiny app. I don't know if you've ever done this before, but I was trying to create an interface for them so that they can do what this Shiny interface does. So basically, I created in R a Shiny app, which basically takes shows what it is that a person needs to do. So if you do run app, this is the only thing that you didn't need to do over here. So basically, I gave this to my collaborator saying, the only thing you need to do is to upload a CSV that has study, sample size, correlation. So very similar to what Kyle did. And if you do this correctly, then it will show you the meta-analysis results over here. So I'll show you this afterwards. And then suddenly everything comes together. But then Kyle came up with what he did. So already amazing stuff from Kyle. And then Jamovi came up and we asked him, can you just do this in Jamovi for us? And he said, yeah, sure. So I think there's also like some data, meta-analysis from Jamovi. So you can have some examples in Jamovi if you want to see how to do correlation coefficients. So what we have here is like the number of the study, the authors, the year, the sample size, the effect size, and then a bunch of controls. Just to see how simple it is, you've got major here. It has correlations or mean differences or proportions or everything else. You just do correlations, and it doesn't get much simpler than this. So you put in the correlations in there, you put in the sample size, you put in the study label, and it just creates everything for you immediately with all the things that are in there. Is it the same one that was just in the... Yeah, it's exactly the same one. So you can see that everything that he did in the online one, you can have here. And you can add a bunch of things. So if you don't want to convert this to Fisher Z, or if you want additional plots, like, I don't know, predictive interval for some reason, you want to do a forest plot that's a little bit different, you want to inverse this, or you want to check for publication bias, like doing a p-curve and a p-uniform, or selection models, like, for example, that's not going to this, but you can do even like a p-curve. So it does that for you, or p-uniform, to see if there's a problem with the publication bias with this stuff. So that's a pretty amazing thing for a few clicks, right? Yeah. All right, so what I would like you to do now is, if you don't have Jamovi, either download this or sit next to somebody who has Jamovi. And what I would like you to do is take my article, 2018 Free Will and Job Satisfaction, and I want you to do a mini meta-analysis of the 3 studies. There are 2 periods, so just time 1. So in time 1, just do this and have a look, and then we'll compare this to the results at the end. And then we'll see if you have some questions or you came up with some stuff, or there's some things that are not clear, and then we'll be able to address this. Any questions about the task to do now? Is it clear? Straightforward? Yeah? How many of you have Jamovi installed? Everything you have Jamovi? Yeah? Good? Not? All of you? Okay. Is the task clear? Are we clear on the task? Yeah? Now, I want to challenge you, because to read an article, you can take a week. I want you to do this in 5 minutes. The whole coding in 5 minutes. To be able to skim through an article, find the correlations within 5 minutes. Are you up for the task? So you've got the article open on one side. You've got the Jamovi open on the other side. And when I say start, you'll need to take out correlation. First, study 1, study 2, study 3. Correlation, sample size, and punch it into Jamovi. Yeah? Up for it? Okay, let's go. 5 minutes. If you have any questions, raise your hand. I'll come to you. First step is go over the article, study 1, study 2, study 3, extract correlation and the sample size. These are the things that you need. We'll get to Jamovi after that. Yeah, you can use the Shiny app as well. Mavis by Kyle, that's a good way. All right. Our 5 minutes are over. Who was able to get some correlations and put them into Jamovi? Raise your hand. Has some kind of result? Some kind of result? We have an error code over here. We have some findings over there. You were got some findings? Okay, terrific. You have a Shiny app, Mavis, right? Okay, so now it's time for us to check this together. Okay, so we now understand that sometimes in order to code an entire article that we know nothing about, you did this in less than 5 minutes. Even with the text, we were able to do this in less than 5 minutes. And especially if we've got a table like this, if it's really organized and it gives us all the information, we should be able to just extract all of that and see effects altogether very easily. So because we've had different people doing different things, so they use the Shiny app, you guys use the Jamovi. Did you overcome your error? Not yet. Okay, we had a little bit of an error, so we'll see perhaps how to solve some of these situations. So we'll start with the Shiny app that we have over here. How to do this? So basically, you've got like a bunch of things here that you maybe don't really need. Yeah, I did this for Marcus already, just so I can demonstrate this to you. So I'm just gonna copy paste this, put it there, add this here, do update view for correlations, and then see what comes out. Yeah, it just takes a while for them to update everything. Okay, yeah, so we've got all of this. This is pretty much what you got in there. Okay, so we'll see. Here we have the forest plot for fixed effects and for random effects, and this is kind of like the summary of the whole thing. So how long did it take us to do the thing? Like five minutes more or less. Let's see how it is with Jamovi. So I've already like created this for Jamovi. Where did I do this? Okay, this ONV file. I'll just also show you how I did this with this very sophisticated Shiny app that I built. It's my first Shiny app ever. I just want to show you what it looks like. So basically, it has this kind of interface, and the only thing that's in this interface is that it gets a CSV file that needs to have study and R. I'll just show you what this CSV file looks like. It looks exactly like so it's just this very simple one. So if I'll just load it into the Shiny app, browse, load it here, 31. So basically it does the same thing. So it shows you the results, it does the random effects, it does this thing. Back then it was revolutionary, but Kyle really did much better than this. Now we're going to do this with the Jamovi. And then we can compare this to what you guys did. So basically you have study 1, 2, 3, N, and R. And if you go and click on this, the correlations go here, the sample size goes there, and the study label goes here. And automatically it creates all of these things for you. Great, love the enthusiasm. Let's take a 10-minute break, come back and do a little bit more. There were some good questions raised. So maybe I'll just repeat what it is that I just, so we want to know what does this, so this is called a forest plot, and this one is called a funnel plot. What do they actually do? So what do they actually represent? If you don't have the same kind of numbers as here, and I think I just saw this in the computer that was shown to me, you're wondering why I called it 0.35, and then it became 0.37. It typically has to do with whether you've used the raw correlation coefficient or whether you've transformed this to R to Z transformation. If you transform this, it does a little bit of a correction and then adjusts the effect size for different things. If you just want to see the way that it is based on the raw correlation, just like change it over here on the side, or you can use the different methods for bias correction as well. For simplicity's sake, we'll just keep this raw correlation coefficient. What does this actually represent? We went over this in our assessment, but I did this super fast, so I'm just gonna say this again so we're all on the same page. What we see here is we have study 1, study 2, study 3. With the different correlation. I'm just going to make this a little bit smaller so everybody can see all of that on the left. So we've got the stuff that we've inputted here on the left. We've got how we enter these things into the different fields, and then we've got the actual results here on the side. So you can see that each study has this line here. It has the effect size and it has the confidence intervals. The way to calculate the confidence interval is basically here in this kind of correlational design. is to create the confidence intervals based on the sample size. So the larger the sample is, the smaller the standard, the error that's around it. So you can see here that the large one, the 14,000, has a very, very narrow confidence interval and a very large rectangle in the middle. And the other ones are a little bit wider. Now, the point that I wanted to reiterate here is that basically when we look at the meta-analysis or a mini meta-analysis, we want to aggregate all three. So what we look at is this model at the end, which has the diamond sort of shape. And we can see that if we take all of these three together, the aggregated effect size is 0.28. Yeah, pretty straightforward stuff. Just share this back. Yeah, if you ever need to justify, I have a few citations for you. I don't know if you remember this paper, but Lakens and Etz, too true to be bad, actually has a Shiny app that is very useful for you. So we talked about these megas. So every JPSP article has like 8 different studies, all of them showing effects, which is quite remarkable. So what they were trying to show in this 2017 paper is just how unlikely this is. And they recommend meta-analysis for that purpose. So the reason why JPSP studies articles always have studies that worked, even when things are very underpowered, is because we have a lot of pressure for positive findings. So we have an aversion to the null. We don't want to publish null findings. So actually, I would recommend that if you have null findings, include those. Report study 3, study 5, study 8 did not work out. But if we do a mini meta-analysis, at the end, we would see that the overall effect is positive, is negative, so forth. Why is it important to include these null findings? Why not just report the positive findings? Because the positive findings indicate a publication bias, and it's also easy to see with this kind of Shiny apps that this is completely unreasonable. So, for example, a JPSP, a Journal of Personality and Social Psychology article from 2010, 2013, has something like 8 different studies. So I'll just punch in 8. All of them are positive. So all of them have results with p-value lower than 0.05. And back then, we have real data from meta-science showing that the power is lower than 35. So if we take the power and we go here to 35, and we ask, what is the likelihood that this is really happening, that we have a JPSP from 2010, 2015, with 8 studies, and all of them are significant when the power is lower than 0.35. What is the likelihood? So thanks to this article, we have a Shiny app that shows you what the likelihood is. And it shows you what is the likelihood that there are significant studies, 0 out of 8, 3 out of 8, 8 out of 8. So probability of observing X out of N significant studies when H0 is true or when H1 is true. So if there is really an effect, when all 8 studies have very low power, so very, very small samples, what is the likelihood that you have 8 out of 8 significant studies? It's this likelihood. It's a very, very small likelihood. So when you read an article from before 2015 that has 8 out of 8 significant findings with very, very small samples, what is the likelihood of this being an actual phenomenon? Very, very, very small. Very, very, very unlikely. Much more likely is the H0, that there is actually no effect in there. It indicates very strong p-hacking, publication bias. People are just not sharing their null findings. So if we would have a method of a mini meta-analysis, there is no problem anymore, because you would say study 3, study 5, study 8 did not work out. Because if you look at this, you can see actually which one is the most likely. 3 out of 8. Sorry, I'll do this. Yeah. So the most likely 27% is 3 out of 8 and 2 out of 8. So these are the most likely. So if we would have a JPSP from 2010 that shows 3 out of 8, we would say, okay, this seems reasonable. If we would have 8 out of 8 significant, this is completely to the point of just being ridiculously unlikely. But more recently, in past few years, we have more and more power because we increase our samples. What happens when we increase our samples? So let's see if we just increase this to 80%, what would happen? And we go back here, which one is the most likely? Actually, 6 out of 8 or 7 out of 8 are most likely. If we have 8 out of 8, the possibility is like 16%, right? So when you do fMRI studies that have very small samples and you've got 4 of them in the same article showing some, just go to this app and see how likely it is that they actually worked. When you have 4 different studies, some of them work, some didn't work, just do a mini meta-analysis and then aggregate everything together, and then you'll know what the likelihood is at the end. Now we're aiming for like 95%, so with your replications of classic effects, 95%. If you have 8 out of 8, but it's very well powered, all of the 8 have very large samples. What is the most likely? The most likely is 8 out of 8, so 66%. So now you have all these tools, shiny apps, in order to see whether things are likely or not likely, right? If we get to the point of 99%, then we know that when we have 8 out of 8 in JPSP, only then do we know this really seems like to be a solid article. As long as things are not well powered, it's very unlikely that all 8 are actually significant. So I hope that more and more journals would have the strength, the courage to publish null findings. And I think it would be a lot easier if you're aiming for JPSP, all these big journals, that if you have a null findings, report it. Just add at the end mini meta-analysis that aggregates everything together and point to this article to show why it is important to do that mini meta-analysis. Anyway, so this is how I explain it. You can cite it the same ways. Okay, so we did this mini meta-analysis. The same Lakens, so the Lakens I just showed you here from Lakens and Etz, is this guy. Best 2 courses that you can invest your time in. Don't take my course, don't take any other course at HKU, just go and listen to Lakens. 2 different courses now available for free in Coursera. Blows my mind. So when I was in Maastricht, Lakens was an hour away. I was very lucky and fortunate that he caught me in the right stage of my career before I was making too many stupid mistakes. So I would go to Eindhoven and take his lectures. And 2 years later, he made this into a Coursera, which is completely remarkable. He's very active on Twitter. He has a podcast, which is fabulous. Like every episode is just on point. So I'll let him talk through what is a meta-analysis. I know I've kind of like skimmed through it, but I'll let him explain what that is and why it's so powerful.
In the previous lecture, we talked about how mixed results are likely to happen. Sometimes you can read the scientific literature and you can find conflicting findings. It's useful to be able to integrate these and to evaluate differences between sets of studies. We can do so through meta-analysis. In some way, if you design and report a study, in the ideal case, it's actually a single data point in a future meta-analysis. Both statistically and philosophically, performing close replications is essential for science. Statistically speaking, because there are always error rates, there's always variation, so repeating a study multiple times gives us a much more reliable estimate of true effects. And philosophically, it's also the same. We like other labs to replicate our studies because there might be unknown small variations, and it's a way to show that results are intersubjectively testable. Other people can find the same thing. So if we have these sets of studies, it's a good idea to actually look at the totality of the evidence. We can use a meta-analysis for this. It can be used to combine either raw effects. If all of the studies have exactly the same dependent variable, you can just pull them all together. Or if all of the studies use slightly different ways to measure something, then we can use standardized effects. And a meta-analysis can be performed on both of these, the raw effects or standardized effects. Let's first think of the question that a meta-analysis actually answers. Very often people treat it as if it gives the final answer. Is there a true effect in the literature, yes or no? But in practice it's hardly this simple. You can even question whether we should think about something as there being a single effect. There are very often in a meta-analysis variations in how we studied something, and these will lead to small variations in the effect size. You can argue that one of the more interesting things to do is actually to ask what sources of variations are there in these sets of studies, and can we theoretically explain them? Or if not, can we develop theoretical ideas that might explain them in the future? So instead of thinking of a meta-analysis as giving a yes or a no answer, it's more an interesting tool to explore variation across studies and to evaluate patterns.
I'm just going to skip one less relevant. Seymour L'Oreal.
If you have identified all the studies that you want to include in your meta-analysis, then for each effect you have to calculate the effect size estimate and its variance. And this is actually all you need to perform the meta-analysis itself. However, as you go through the literature, it's also advisable to code variables that might explain variation across studies. You might think about the country in which study was performed or the type of manipulation that was used in an experiment. Calculating the effect size and its variance is actually relatively straightforward, if enough data is presented in the original articles, which is regrettably not always the case. For this reason, making raw data available is very recommended because it will make future meta-analyses much easier. If all the data that you need to calculate the effect size is available, such as means and standard deviations, and for within designs, correlations between dependent variables, you can quite easily calculate the effect size and the variance, and this is all you need. Now, I realized that performing a meta-analysis itself is not actually as difficult as I always thought. I remember that I once talked to somebody who publishes quite a lot of meta-analysis and helps other people to perform meta-analysis. And I said, yeah, it's actually much less difficult than I thought. And she said, yes, shh, don't tell anyone, because now they actually ask me for help. Now, there are a lot of complexities in doing a meta-analysis, in coding everything accurately, and also in accounting for things like bias. So it's not that a meta-analysis in itself is extremely easy to do. There are definitely some difficulties. But it's easy enough to try to do this if you start with a new research line, as you're reading the literature anyway, to also code the effects and the effect sizes and the sample sizes of the studies you're reading, so that you can also have a more quantitative evaluation of all the evidence.
I recommend it. It's very approachable. So if at any point you have things that you want to talk to him about, the podcast is actually doing with a PhD student, and they're discussing all sorts of things. And it just happened with him responding to an email, asking him something about methods. So very approachable and very active on Twitter, and helps a lot. So I recommend you to take these two courses, interact with him, follow him, listen to the podcast. Really good stuff. Change the way that I do science. So two of us here already brought things all the way through to a preprint, hopefully soon a publication. What does a meta-analysis look like? Aside from the process of actually extracting the correlations from the article and putting this in Jamovi, is there more to this than that? So there is a little bit more to that. So we need a protocol, we need to search, we need to screen, we need to extract the data just like we did right now. Then we need to do some quality assessment, and then we need to synthesize everything together and write down the results. So just to show you, for example, this is a meta-analysis that I've done with Lucas. This is the first meta-analysis that I've done in Maastricht. So this is part of his two-stage one-year thesis in master's. And we've done the exceptionality effect. So I think by now you're very familiar with the exceptionality effect. We were trying to see how many are there in the literature. So we did very specific types of searches. We've identified 2,500. We also did a bunch of calls on listservs and mailing lists and other methods to say, if you have any data, please send this to us. We coded all the emails and contact information of all the people who published on this, and then we sent them emails. Do you have anything in your file drawer or something that we haven't found? And we have identified 83 additional things that we were not able to find through the literature. Then we do something like a duplicate to see how many duplicates we have, to see whether it's the same thesis or preprint and publication. So we just eliminated all the duplications. So that was like 921. And then we did a bunch of exclusions that we pre-registered. That took a lot out. So 852 out of the 921 did not meet that. And then we've accessed the full text, excluded a bunch of things out of that. So starting off with something like 2,500, at the end, we only had 23 articles that met our pre-registered exclusion criteria, out of which we had 48 different effects. So it sounds a little bit like the trait sleep study, about the same kind of, but it's not considered to be a very large literature. We were hoping actually to have a lot more than that. At the beginning, when I did this meta-analysis, I thought it would be more like 100 articles, 400 effects, but this is what you get with these kinds of studies. So if we want to see what a search looks like, this is one of the, so I did a meta-analysis workshop in Singapore where I worked with a bunch of them over a course of 2 weeks, where we did 4 different sessions and we hackathon, wrote things together, coded things together, searched things together, and we submitted this as a register report to a journal. I want to show you what a coding sheet looks like, because I think that's perhaps one of the hardest things to do in a meta-analysis, to do that in a way that would allow a team, and you can see all the PhD students here all together. So Kevin is now an assistant professor in Shenzhen. I forgot which university. And Velvet just told me that she got a position somewhere after being a PhD in the UK, postdoc in the UK. Krishna is now a full professor in Polytechnic University in Hong Kong. So he moved to Hong Kong after being in NTU in Singapore. So we did all these things together, submitted this, and now it's in principle acceptance. But they've already completed the search and the coding. And I want to show you how detailed their Google Sheet actually is. You can see that Kevin is very detail-oriented. So he did a bunch of amazing, very detailed instructions for all the team on how to do the search using something, Publish or Perish. Have you ever used this tool, Publish or Perish? Never heard of it? No? Okay, so I'll demonstrate this to you. It allows you to very quickly find things, code them, extract them, put them in a CSV, and then give this to different people in the team. You can see the timeline. So we ran this before the pandemic, 2019. They really started working on this during the pandemic, but a lot of things have happened. So you can see the different roles, coding phase, all the verification, and all of that. You can see all the emails that we sent all the people to ask them for information. So we have the template that we created. We sent this into 2021. And then every email that we got back, everything that we sent out, everything has been logged in here. This is the most important page. This is the thing that you want to aim for. You can see that the different colors, they've separated this. Where is this? Yeah, so there's different backgrounds for the different team members being in charge of different things. So I don't know if you can really see the colors here. But anyway, it's separated between the team members. You can see which team member is in charge of what. You can see the coder. You can see the source, published or not published. And we really try to make this as reproducible as possible. So not only, from in the Jamovi, the way that you saw, the Jamovi is like, okay, study 1, this is the correlation, and this is the sample size. But we wanted to be very, very clear. Where was this information extracted from? Is it table 1? Where in table 1? Is it the text? Is it perhaps table 6? so that if there is a misalignment, table 6 and table 1 and the text don't match, then we know how it is that they coded everything. So if you'll go here, you'll see that we have things about the paper. So each paper has some information. Then there's demographics. Then there is the IV. So you can see IV description. Which page was it? 19. Which page was it? 1426. Which scale was used? Was it the whole scale or was it a subscale? Is it in the right direction or the wrong direction? So, for example, if we're looking at association with sleep, is it the lack of sleep? What kind of sleep? Is it the duration? Is it the amount of time? So different aspects of the larger construct that you're looking at. But here, very, very important that in some cases, some of the measures are reversed. So we need to know whether we need to reverse them back. If we run correlational studies, it's also important we can account for reliability. So we can't code things like alpha, Cronbach alpha or omega. What is the dependent variable? What is the, which page is that on? And then finally, we've got the moderators. So different kinds of moderators that are here. And then we've got the statistics. So you can see we've got like the effect, the degrees of freedom. Is it equal? What is the p-value that's extracted? If they reported any other effect size. Also, all sorts of other information. Occasionally, if they was extracted from a linear regression rather than a correlation. Degrees of freedom perhaps are not exactly calculated correctly. And then for each one of those, we have a checker. And if everything is okay, good. If there's some kind of misalignment, then we have a third checker, which is usually me or Krishna, like the more senior people, to look at any disagreements between those. And then whether this was checked or not checked at the end. So once we have all of this, then we can more easily transfer this into Jamovi or a metaphor or anything. But it's very important to allow this for, exactly who coded, what date, where did it code this from, and a bunch of other factors that are in there. There's also a code book. So all the things that we coded, what do they actually mean? All the listservs. This is the list of the different types of things that can be entered into each field. These are all the search patterns. So if we say we search the literature for association between the free will beliefs and job satisfaction, how did you search? What was the search pattern? Can we see that? So we've actually documented exactly what it is that we search for. So free will or free minus will or freedom of will or determinism. And so very important to be very systematic and code all of that. So Kevin did a really good job here. We did some pre-testing before with some dummy data that we created. All the search patterns are like here. Anything else? They did a bit of a competition between them. Who is the most prolific? Yeah, the mail merge, how they sent, who was sent, which email, how did they respond, and so forth. So basically, as you can see, this is public, so you can take and use that. But I'll also show you a template that we created that you can just take and use for your own project if you need to create this on. So maybe I'll just show you this publish or perish thing. I hope I have this installed. Yeah. All right. So I'll just shift to this. So it's very useful for you also when you are doing a search for your thesis. You can search very easily, like Google Scholar or Microsoft Academic. These are the free ones, or you can search profiles and all that. I haven't used this in a while, but it should be pretty straightforward. Let's go back. Let's do a Google Scholar search. So you can search by authors. For example, if you want to search Feldman, it has some limitations. For example, it will only give you 1,000. I think it can only ping a certain amount of, but it will do all the extractions for you. So if you just do this on Google Scholar, there's no easy way to export this. But if you use publish or perish, it would just allow you to export all of this into a CSV. You can copy the results, you can save the result. So it just makes everything a lot more reproducible. There's probably going to be a lot of Feldman that are not me. So I don't know what's going to come out of this. Yeah, so all of this is here. You can see the rank, the authors, the title, the publication, and all of that. I don't know if I will put my full name here, what would come out, but you can save all these results as a CSV. You can import this into, I don't know, Zotero or whatever it is that you use, EndNote. So this is a very easy way to look at all that. So if, for example, I want, I don't know, free will. So here, it just showed you how it, and you can see I had like 2 papers on this, which are basically the same one. Yeah, so first we did this in a conference, then it ended up being here. But as you can see, very easy way for you to do this. And if you work with a team, and all of you need to do certain searches, this is how the coordinator makes sure that everybody searched the right way. And then you can import this the same way that Kevin did things, okay? Strongly recommend this Publish and Perish. Very powerful for you to do your literature reviews. So many things that you have that you used to do manually or search on Google Scholar, there's tools that you can use that are very, very useful. And I strongly recommend just go to the meta-analysis syllabus and you'll see those. So this is one of the tools. There's another one called Citation Chaser, Lens. Anyway, a bunch of things for you to do everything automatically. And now we've got more and more advanced ChatGPT-like AI tools that would extract things from the literature for you. So you wouldn't have to go through all of the articles one by one and read the entire thing. So I did a bunch of screenshots from Citation Chaser. No need to do that now, but it just does what Publish and Perish does with a Shiny App R interface if you want this. Any questions about this so far? It's pretty straightforward, right? So I think by now we all understand pretty much what is a meta-analysis. We have a very broad idea of the kind of process that you need to go through. We now understand that the coding is pretty straightforward, especially for correlations, and that the actual technique, the statistical technique, can be done with Jamovi or a metaphor or all of those, very straightforward, very, very fast. But now I want to discuss a few issues with you regarding a meta-analysis. So it doesn't matter if you do a meta-analysis or if you read a meta-analysis, you want to know whether a meta-analysis has done a job well, or can you rely on this for your thesis, yes or no? So I want to give you an example that I just ran into because of Adrian. So Adrian is one of the people that I mentioned. He's on the meta-analysis syllabus, and he has helped develop some of these templates. Low ball technique, I teach this in my classes. I don't know if you're familiar with the low ball technique, but this is a very straightforward influence technique. I think all of you can recognize this technique that is happening all the time. So, for example, it's an preliminary, the decision to take action tends to persist even at the cost of performing the action have increased. So, for example, you sell something and you say it's only $200, and somebody says, "Wow, $200 is amazing! I'm in." And then 15 minutes later, says, "No, sorry, this is without taxes. So now add the taxes." And the person is like, "It's not $200, but now even with the taxes, I still want this because I've already said yes to this." So it's only $200. So let's say you walk into a dealership, you want to buy a car or a computer or whatever it is that you're into, $200 only. And then you say, "Wow, I'm in." Once you've got this commitment, then they say, "No, but it's actually $300 if you do this and that." And then people say, still, it's okay. So it's a very simple, straightforward, low-ball technique. I teach this in psychology, in judgment decision-making. And I wanted to know, does this really hold? So this was published in the 1960s or 70s, became a very famous book called Influence. So I wanted to look into this, and I found this meta-analysis, which looked really good. So I love meta-analysis, and I wanted to see like how solid is this. So they found 23 different studies and 44 subgroups, and then they overall sample size of 4,733. So I thought, okay, not a lot of studies, but overall with almost 5,000 participants, then we can maybe say something meaningful to see how strong is this effect. So I'm looking at this correlation here, and I'm seeing R equals 0.16, which is somewhere between a weak effect and a moderate effect. This is kind of like a common effect, I would say, in social psychology, not without any meaning. Yeah. And when I look at these findings, I noticed the first one that was published in 1978, Cialdini with his colleagues. So Cialdini is the person who published the book Influence. This is how it was coded. So I'm like, yeah, I started talking about this in my classes and saying, yes, there's this meta-analysis. Go look at the meta-analysis. There is some evidence. R equals 0.16. But then I saw another meta-analysis that just came out in 2015, and it had somewhat different studies. So they did a different search and they found different studies. But interestingly, it also had the same kind of Cialdini et al. From 1978 for the same kind of studies. So you can see them here and you can see them here. So I was, at the beginning, I just wanted to see, okay, so we've got these two. I just wanted to make sure that they're exactly the same. And when I put them against each other, I realized they're not the same. So if you look at these numbers, the green ones seem to be okay. So 60, 60, okay, 31.3, 31.3, 2020. It doesn't seem like a small error. It seems like completely different numbers, because if you compare this one here, 24.1 to 31.0, it's obvious that one of them has to be right and one of them has to be wrong. But you've got two meta-analyses showing you the same, coding the same articles, but showing you different stats for that. Which is why it's very, very important to have reproducible meta-analysis so that we know what is it that they coded, so that we can go back and check. Rather than saying, okay, both of you are wrong, or there's some inconsistency, solve this. We want to be able to see where they got this from. Perhaps they have some problem in the original experiment. Perhaps the reporting is very limited. Perhaps some people had access to some information that we don't have, that wasn't published. We don't really know what's happening, but this already got me worried about this literature. So I thought, okay, this is an interesting case. So actually, I posted this on Twitter, and I asked the people who know meta-analysis, I asked, has this ever happened to you? How common is this really? And that's when I discovered many other things. A whole new discipline called meta-science. Some of this we discussed before. The guy is well known. This is like an understatement. Does very good work, goes around the world, talks about a lot of things in medicine. So he's not even a psychologist. In 2005, he published this seminal paper, which got a lot of people very upset. If I would publish this kind of paper, nobody would ever listen. But if John Ioannidis publishes this kind of paper, people really do listen. Why most published research findings are false. It took us about 6 years in social psychology to listen to John Ioannidis, to try and understand what is the replication crisis. But I just want to tell you, when John Ioannidis says something, we listen. So this started a lot of things. What does John Ioannidis have to say about meta-analysis in general? This is his title: The Mass Production of Redundant, Misleading, and Conflicted Systematic Reviews of Meta-Analysis. He gives us this kind of graph, and in this graph, he summarizes that 3%, only 3% of meta-analysis are decent and clinically useful. 3%. He did a search, a meta-science search and coding, and showed the exponential growth of meta-analysis. He has shown that in some journals, you have more meta-analysis articles published than actual articles that these meta-analysis aim to summarize. And he also does this very interesting analysis of different countries in the world. And I think our region, China, really picked up on this. So a lot of meta-analysis coming from this region. And we don't know how useful these meta-analysis really are. So you can see his summary over here. Many of them are unpublished, some of them are redundant and unnecessary. He has all sorts of criteria for this. Decent but not useful, we can argue about this. Misleading, 13%. Flawed beyond repair, 20%. Back then, when he came out with this, he really likes to shock the world. We kind of laughed it off and said, okay, we have some problems. We can deal with this. We can do all sorts of things. But actually, Daniel Lakens, with the nice shirts that you saw, is the person who started to recode meta-analysis. And I can share some data with you that him and his team revisited meta-analysis, looking at the same articles that these meta-analyses have already coded. And he has shown that he's only been able to start with 50% of the meta-analyses that to verify. And out of the 50% that he started to verify, he found that half of those, so 25%, were completely flawed and sometimes went in the actual opposite direction of what it is that they were trying to. So when he went with an additional team coding those meta-analyses again, he found that the meta-analysis people made very, very bad mistakes that completely reversed the whole thing. So we're talking about 25% are utterly flawed, completely unreasonable, and beyond repair, which is kind of like in line, 20 to 25% with Ioannidis. And we're not talking about social psychology. Ioannidis did this in medicine and in other fields as well. Another study that came out, nearly 80 systematic reviews were published each day, so another exponential growth of meta-analysis. So just a bunch of these things. So I have my own solutions to meta-analysis and how we can improve them. I really believe in pre-registrations and registrar reports. This is the way to do things. So we've got the community helping out, and you've got reviewers going over your search, your code, your analysis, everything that is planned. And we do need full transparency, just like Daniel Lakens was telling you in the video. If we don't have that, we have no idea how they coded things and what we can actually do with that. So I'm going to discuss three major issues with meta-analysis. The first one is that meta-analysis are very, very tricky because they have a lot of freedom and flexibility in them. So here is, for example, out of 54 meta-analysis in Psychological Bulletin, our top journal for meta-analysis, Perspective of Psychological Science, top journal. Only 7% followed some guidelines, and the guidelines are supposed to standardize everything. And only 67% of them shared any data about what it is that they did. Now, you can say about your own study, your fMRI, your participant, perhaps there's issues of privacy, perhaps there's some reasons not to share. If this is a meta-analysis, it should be based on things that are already published. So there's no reason not to share this fully. Issue 2, meta-analysis reflects published literature, but there's a lot of noise and bias. So I'm going to skip this one. I'm going to discuss a case study. This is a real case study that has hurt me personally, because during my PhD, I took a one-year exchange to the US to work with a lab. I was in a management business school, and I wanted for the first time in my life to see social psychology department and the lab. And it was one of the biggest labs. I learned a lot, met some incredible people, very grateful for that time. But a lot of people there did stuff on something called ego depletion. I'll just say very briefly what ego depletion is. In social psychology, we love to discuss willpower. So willpower is one of the strongest things that we told people that they should invest in. So classic marshmallow studies in the 1960s to the 1980s show that if people are able to overcome themselves and show willpower to resist the one marshmallow for 10 minutes, then getting a second one 10 minutes later after they waited, showed 20 years later, showed some remarkable things about career, health, relationships, and so forth. So there was this idea that if you have strong willpower, if you're able to overcome temptation in order to plan for the long term, then you're able to get good results in your life across many, many domains. Ego depletion took this one step further. It said, unlike intelligence, so intelligence is fixed. If you have intelligence, great. If you don't, nothing much that you can really do about this. But willpower is a little bit like a muscle. You can go to the gym and work on your muscle. You can work on willpower. You can train your kids to resist that marshmallow and wait for 10 minutes to get the second marshmallow. And another function of being a muscle is that the more that you exert willpower, if you spend willpower, so the whole day you spend your time punching the keyboard or sitting in boring lectures, so you have to spend a lot of willpower in order to sit there quietly when somebody is talking blah, blah in the background. But then you come home and you've exerted all your willpower. You have none left. And then you snap and you fight and you argue with your loved ones, the people that you want to spend the most time with. Right? So why do we do this? Why is it that we can't just like be ourselves when we come back home tired? It's because we've exerted all of our willpower. So all of us can empathize, can feel that this really speaks to us. We really feel that willpower is limited and that we snap, we lose willpower after we're tired. So ego depletion was a very big field. How big? I took Publish and Perish and I did a search. So the number one person who started this, two actually, so Roy Baumeister, who I visited in Florida, and Kathleen Voss in Minnesota, are the two people who started this whole idea of ego depletion, invested in this a lot. First publication started in 1998, but if you go into this, you can see number of papers, 730. How many citations? 57,000. So for 2 decades, I was utterly convinced that ego depletion must be a phenomenon. It's like, it's the best that we have out there. I saw these things and I thought, this is amazing. You know, this is the kind of stuff that I want to do when I grow up. Yeah, 2010. So I did my exchange in 2012. 2010, this meta-analysis came up. And for me, you know, I look at meta-analysis. Meta-analysis is the number one thing. I thought this is amazing because what this actually showed, now you should know pretty much how to read this thing. You have the number of effects, you have the number of participants, and then you have the effect size. So the overall effect size was a Cohen's d of 0.62, which is very impressive. We don't have a lot of evidence in social psychology that shows 0.62. And look at the number of effects. It's nothing like 25, 23, 40. We're talking about like 198 effects. So very, very large literature, all of them showing this effect, concluding that ego depletion is a very strong phenomenon after 2 decades of research. So I came into that lab with that kind of feeling that I'm really in a very strong environment. They've identified a bunch of factors, moderating factors. So actually you can make ego depletion stronger up to 0.82 if you include choice and volition. So there's a bunch of factors, but as you can see, all of these Ds are pretty decent, pretty strong. All of them are above medium. The first indication of trouble came long after I came back to Hong Kong to finish my PhD, is that a few years, so this is 2014, I don't know if you can see this, 2014 came out this paper saying that it seems to be like in the meta-analysis, there's an indication for a publication bias. So they did this thing, which at the beginning I couldn't really understand what is going on here. They showed all of so on one side, we have standard error. So how much of an error is it? So how large the sample is. And on the other side, we have the effect size. And you can see sometimes we have effect size of like Cohen's d of 3, which is amazing, right? But then we have a very large, very, very noisy. So it's over here. And we've got all of the distribution here showing under this triangle over here. Most of them falling under this triangle that shows the 0.64. But there was a very, very strange pattern because most of these dots here were just on the border of a different triangle, and that triangle was the triangle around the 0. So the triangle around the zero shows no effect whatsoever. So it seems like there should be a lot of studies here in the overlap between these two triangles, but actually a lot of these studies here in the null triangle are missing. They're not there. And they've developed, first time in 2014, we did not have a method for that before, saying that perhaps this is an indication of a publication bias. So the original one, the one from 2010, showed an effect size of 0.62. However, when we applied methods for estimating and correcting small study effects, we found very strong signals of publication bias, along with an indication that the depletion effect is actually no different from zero. So I don't think I need to go into too many words to say that back in 2014, these scholars were not very popular. So coming against one of the biggest things that social psychology have said, with a very strong lab, very prolific researchers, to say that actually all of this is basically zero and all of the effects are happening because of publication bias, impossible, just seemed impossible. So after you apply all of the fixes, you see that under PET, it seems like an effect size of minus Cohen's d of 0.1. So suddenly we had these two different methods, PET and PEACE, estimating publication bias and then even being able to adjust for it. So this Carter, and actually both of them are very well known, which is I think why it was eventually published, started doing more and more of these different ways of estimating publication bias. So they started to come up with more of this. We find very little evidence that the depletion effect is a real phenomenon, and so forth and so forth. More from other researchers in psychological research coming up with more information, some of them saying, but PET piece is not really a good technique. You haven't done this correctly. You need to do this a different way. So just a lot of discussions. Now, I just want to make clear that you know how to read this funnel plot. If we have the funnel plot with no effect whatsoever, this is what it should look like. So this is simulated data. When you have simulated data, all of them should fall somewhere like this. So you can see it's mostly after maybe one or two not under the triangle. If you discard the non-significant, only those will appear. But in order for those to be there, it just means that there's like a ton that is just not shared with anybody. So if we only see the observed results of these ones and all these disappear, then you can see that just like a bunch of people over the years have conducted all of these studies, but nobody has ever shared this with anybody else. And another meta-analysis came out on priming research, which is Kathleen Voss. It's the same Kathleen Voss from ego depletion. She published a paper in Science in 2006 showing that if you display money in the screensaver or next to your stimuli, you run, if you're in vision, you run dots, you do all sorts of things, but then if money is running on the side, then it gets you to be more selfish. Science paper, 9 different studies showing this effect. And the question is this a real effect or not? And for the first time, we saw all of these funnel plots in one place showing just how ridiculous this thing is when we compare all of the published findings, all of the unpublished findings, and then compare the published findings to the ones that had a pre-registration. So if we look at this one over here on the left, you can see all the studies, which is 289. After a science paper about money comes out, a lot of people want to do this. You can see all of these things that are published here on the right, just below 0.05, and not a lot of them in the null triangle. If you look at the unpublished studies, you can actually see most of them are under the null triangle. But what is really interesting is this part with the published studies. So published studies over here is the same pattern. Pre-registered effects, which they had 51 of, just falls very neatly under the null triangle. So people ask, does pre-registration help? Does looking at unpublished literature help? It really does. So when you do a meta-analysis, it's not enough to look at the published literature. You need to look at all the preprints, the thesis. You need to reach out to people, ask them to share their file drawer. And only then, if you really have some indication of the unpublished literature, if you have some indication of what's the literature on registry reports or pre-registrations, only then can you really conclude that you have an effect or not. So just so we understand what the difference is, money priming seems to be, the meta-analysis suggested the money priming is 0.35, which is a reasonable coherence D that I would suggest any intervention based on, especially if it's something silly like putting money around. You know, if I can have a meaningful intervention with just like having dollar bills flowing around in the screen, that's terrific. But when we look at the pre-registered effects, it's 0.02. So the whole thing basically disappears. So I showed you a bunch of methods to estimate publication bias. One of the things that we talked about was P-curve. So I'm not going to go more into this. I'm going to skip this whole thing. But when they did the P-curve over the ego depletion literature, this is what they found. Just below 0.05 is the highest, and then it decreases, which is exactly the opposite from what you would expect from a true effect. So it seems like when you apply all sorts of publication bias adjustments or P-curve, then the whole thing disappears. So I'm just gonna go back to this because just look at this literature. 730 published findings. For every one of those need to be at least 10 that are not published. So we're talking about 7,300 papers, preprints in this literature over 2 decades with 57,000 citations. And after 2 decades of doing literature on this, entire careers, people built their entire reputations based on this. Now we conclude that suddenly there's like nothing in ego depletion. So that makes me like very sad. So I give lectures about this. I also play some parts from a podcast. I'm not going to do this here, but people were affected by this. This was devastating for a lot of people. So this is a summary, a very disturbing summary of what happened with the meta-analysis. So just to recap, we started in 2010 thinking that our effect is 0.62. But then after all the inventions of all the publication bias adjustments, we realized that actually it's much closer to 0. Finally, Michael Inslet, I think you can see him here somewhere. Was part of this big group that did an RRR. This is a meta-analysis of all the RRR of this ego depletion classic study, 0.68. Finally, at the end, the effect was 0. So a lot of people are very, very disappointed with this. So actually, when we did a mass replication effort that was a registry report, it was very close to what the effects were after publication bias adjustments. We asked Baumeister and Kathleen Voss, what do you think about this? They did not like this at all. So they had all kinds of, misguided effort with elusive implications. You didn't replicate the right thing. But at the end, they took responsibility. And Kathleen Voss said, we will organize a pre-registered multi-replication project next year. And this was 2016. So we really were hoping that Kathleen Voss and Rory Baumeister, and me especially, like I know these personally, I know so many people from that lab. I was really cheering for them to be able to show us that ego depletion is a real thing. So we waited for 2 years for them to come out. And this is what came out after 2 years. So Kathleen Voss was the lead on this, published in Psychological Science. Finally, what is the effect? It's nothing. It's just the same as the first one. More labs, more participants all over, 2 mass replication efforts with a bunch of meta-analysis with publication bias adjustments after 2 decades, 57,000 citations, 700 articles, shows nothing. Ego depletion just is not a thing. Devastating, heartbreaking. Really don't know what to do with this. Then surprised me, HKU surprised me, because people that I know here came out with this mass replication from this region, from our region, saying that data from 12 labs across the globe with 2,000 participants revealed a small and significant ego depletion effect. but I don't think they've read their own findings. Finally, what they found was D equals 0.10. So they found a Cohen's D of 0.10. And based on this, they concluded this is support for ego depletion. So yeah, Bill here was a TA in my course, definitely an open science guy, supports this. Now he's got a job in mainland China. I was asking him, what's going on? Like, what do you think you did over here? He says, no, we found support for ego depletion. Like, did you really? So what is the support? 0.10. How different is this from Kathleen Voss? 0.06, 0.10. I don't really understand this. So I asked him, okay, so now I want to do an ego depletion study. What do you think? How many participants do you think I should use? So we went back to the effect size confidence intervals guide that he also helped to do. And I asked him, yeah, let's do a power analysis. You said ego depletion exists, 0.10. Let's run this. We look at all these benchmarks. Let's run this. How many participants do you need? Only 1,237 in each group. So you need two conditions. Altogether, 2,500 participants. Then you'll have an ego depletion effect. So I don't know what they were doing this, concluding that there's significant. In a meta-analysis, once you have a large sample, you find everything is significant, but you need to look at the effect size. So not only Kathleen Voss, not only the mass replication, but also here in this region, with our very own people at HKU, with their own conclusions, show that ego depletion can just not be studied by us. If there is anything in there, it's just like so tiny. We need to invest our efforts in something else. So very unfortunate. This is my conclusion from this whole thing. Don't look at p-values in a meta-analysis, because once you have a large sample, p-values are very, very sensitive to that. Everything can become significant. Look at the effect size, and the effect size for ego depletion just doesn't mean anything. But it does mean that if you do a proper meta-analysis and you look at publication bias, then you can learn real things. So if you are planning a thesis, don't just read a meta-analysis as, yes, we found support, therefore read. First look at the effect size, then look at whether they did publication bias adjustments, and make sure that everything is proper. Did they do open science? Did they share everything? Did they code this correctly? Did they? So all the things that we discussed here. Yes. Okay, so we have a bunch of ways to look for publication. I'm going to skip this, look at different things. Main thing I wanted to show you is that if you have a meta-analysis and you want to know, so we have so many methods for publication bias adjustments. We've done good work in the last 10 years to adjust for these things. How do you know which one to trust? Because they show different effects. So now we've got this Shiny app, but Carter, really good work. You can go on this Meta Explorer, and it will show you how, according to different ones, which one is the most suitable for your data. They all have strengths and weaknesses. So if you want to know which one should I use, I really recommend it. Does a showdown of looking at all these things together, giving you funnel plots, looking at the hypothesis test, all sorts of benchmarks, really, really terrific stuff. So all the code is open. You can actually embed this very easily in your R code in order to make sure that you've addressed on this. And now it's mandatory in places like Psychological Bulletin, or I don't know exactly that journal that you're aiming for, but you need to show that you've looked at publication bias. Because we don't have transparency, we don't have error detection, we don't have reproducibility, it's very difficult to know just how good things are. So once again, meta-science evidence, how many people are sharing all sorts of things, very poor practices in terms of reproducibility, summary statistics. So if we look at meta-analysis and what it is that they report, meta-analysis are actually very badly conducted. So I really hope that if you're doing a meta-analysis, not only will you share all your data, but you'll be very transparent, just like Kevin did. Where did you take this from? Which page is it on? What is it that you coded? Is it really verified? Step by step to make sure that all the data is there if somebody wants to verify all of that. But really horrific practices all across. This is one attempt to look at 33 published meta-analyses where they looked at almost, so they had 224 effects. Almost half of the sample primary effects could not be reproduced based on the reported information in the meta-analysis, mostly because of incomplete or missing information. Daniel Lakens here with this group that I told you about in 2013, 2014 coded 54 meta-analyses. Around 50% they couldn't just even start because nobody would give them the data. I don't know why anybody would hide this kind of data given that it's all public out there, but only 25% of that was meaningful and corrected. So you can and correct. So you can look at the what they did over there. These are from their slides. Oh yeah, and I did add one last one about fraud. When you do code things in your meta-analysis, just make sure that you're not coding things that have already been flagged as fraud. That's an unfortunate thing. So for example, we see, this is from a Twitter that I got recently. So looking at a meta-analysis, and it included 3 studies by somebody who we now know has been expelled from Cornell, did a bunch of p-hacking / fraud things. So you can just see from the citations, his name just keeps showing up. Really need to clear the literature, but we don't issue corrections. We don't retract. Now Zotero has this function. Publish and Perish has something in order to tell you if something has been flagged as fraud. But we really need to be very, very careful. Dorothy Bishop is trying to clean up the literature by flagging predatory journals. Just be very, very careful what you're coding and where it comes from. Yeah. Finally, solutions. Daniel Quintana, also a person, he has the podcast called Everything Hurts. Dan Quintana is a gifted communicator of science. So if you want to know how to pre-register your meta-analysis, he has much better videos than I do, and he's much easier to listen to. And he has a whole workshop talking about how to do this. He also recently introduced a really nice Power R meta package that you can easily use. We've teamed up actually some HKU students. Kit, who is now a PhD student at Chinese University of Hong Kong, joined. These are PhD students from the UK who worked with Dorothy Bishop. And they've created this beautiful standard. So if you're doing a systematic review, they have a way to support you with some templates. And this is ours. So if you want how to do a reproducible meta-analysis, I gave a 3-hour workshop. Adrian followed up in Birmingham to say how to use his templates. And I'm just going to show you my example. So this is on my website. If you want to learn how to do meta-analysis well, together with Kit in Chinese U and Adrian in Cyprus, we created 2 templates for experimental meta-analysis and a correlational meta-analysis. So if you want out of the box to do what it is that Kevin did, so a coding sheet, you can just like open these 2 coding sheets. You can also have a main manuscript. So just like you have a main manuscript for your replication projects, we have a main manuscript for a meta-analysis, which just takes you step by step through the whole thing, what it is that you need to include, screening, inclusion, coding, pre-registrations, design. It just like has everything already out of the box for you, just to make sure that you've tackled every aspect of those. You can also see how detailed the coding sheet is. So it gives you like a template and also some simulated data to see how to get to the same level of transparency like Kevin. And to supplement that, we also have the R Markdown code for all of that. So you can go to the OSF and you can download the R code that runs on the coding sheet with some simulated data. So all you need to do is change the simulated data to your own data. If you're doing correlations, you have one. If you're doing experimental, you have a different one. All this to just make it as easy as possible for you, just like we did with Jamovi, easy for you to just punch in the numbers and make sure that you have like a solid, reproducible meta-analysis. So I do recommend that if you care about this, if I would be you, if I would be taking my PhD again or doing an MPhil, I would start from a meta-analysis. There are tools for you to do this well. Constructed, created by people here at HKU. You can even talk to Kit at Chinese U. He'd be happy to do Zoom or come work with you on this. He's very passionate about this. He's also prolific. It's amazing how many people he collaborates with right now. Amazing job. And it's no longer just me, him, and Adrian. The entire community is involved in this. So you'll see like a bunch of people here from all over the world are helping us making this really very, very solid, taking you step by step. And for example, with Kit, we just got in principle acceptance from peer community for a meta-analysis on the action effect. So a lot you can learn from him. If you don't want to talk to me, you can talk to Kit. He's very, very responsive. Everything from his project is here using the simulated data. If you want to hear from Adrian about what it's like to do a meta-analysis, what is it to do a project with us, if you want him to help you, he has now a new channel on YouTube. So now the Meta Science group in Cyprus, which Adrian is there, is doing a series of wonderful meta science YouTube. So go listen to him. He says how he got involved with HKU and us and me and Kit. Really, really inspiring stuff. Last thing, the Singaporean bunch. So Kevin, who is now in Shenzhen, and Velvet, just talk about the process of what it was like to do meta-analysis. I think they were very scared at first. I'm just going to play Velvetina, so you hear a little bit from her, because I think hearing this from me, it's tiring, it's not very convincing, but hearing this from a fellow PhD student who has done this just like you, I think would be a better process. And we're about to finish the stage 2 for this. It's almost completed. So she's done very, very well.
Hi, my name is Velvetina, and I'm a PhD student at the UCL School of Management in the UK. I've always been very interested in the concept of open science, where we can conduct reliable research that's upheld to the highest standards of transparency and rigor. And my current experience in working with Gilad on a registered report meta-analysis has been very enlightening, and it provided me with a very realistic perspective on what it actually means to be open. So the idea of open science has been always very grand and inspirational to me, but in reality, it really required me to think in a very focused manner and to actually kind of retrain myself to consider the entire research process. And fortunately, for me, as someone who's at an early stage in my research career, I think this actually makes it easier for me to adapt to a new way of thinking. And I just wanted to point out, as an example, in a standard meta-analysis, when you're actually planning on what you want to do at the start, you may not necessarily anticipate issues that you might encounter at each stage of the analytic process, such as identifying papers with inconsistent results, or even thinking about how the final data set needs to be structured for an accurate and efficient analysis. And fortunately, as someone who is very new to meta-analysis, being able to do it in a registered report format enabled me to get feedback earlier as from reviewers in order to consider how I can anticipate and also plan for these issues that I may encounter. And it also actually enables me to save time and really be able to conduct research in a much better quality. And what really stood out for me actually was how this need to be transparent really translated into a really detailed thinking for all aspects of your research. And this has influenced in other parts of my study. In experiments I've run in the past year, I've aimed to pre-register them And even in writing out the experimental design and the process of collection and analysis, I myself have identified issues and flaws in my methodology that I was able to correct for before I ran the experiments. And in return, this saves me so much time and resources that would have otherwise been wasted in conducting a bad experiment.
Okay, it keeps on going. I'll let you listen to Kevin some other time. I'm just going to summarize Krishna, the professor, the full professor in PolyU. He, after the workshop, trying this together with us, Reggie Report, felt after so many years being a full professor that this was by far the most rewarding research experience that he has had. So he has done meta-analysis before, he has done research before, but doing this in a transparent way really was very rewarding for him. And what he liked is that there was clarity. There was no second guessing for anything in the process. So that's it for me about the meta-analysis. I know this was like very brief and didn't cover everything, and you might have a lot of questions about the process and all of that, but this was meant to be a teaser for you to get interested in this. If you want to know more about the meta-analysis, I will be conducting a full-on workshop. I think it's aimed for February. So we'll do a couple of sessions, half a day here, half a day 3 days later. So like 2 parts, and it will be online. So you don't have to like come physically. It will involve a lot of different people from around the world who requested this, and we're going to do a hands-on meta-analysis together. So we're going to tackle this together. So just like I did this in Singapore, we're going to do this into a hackathon. We're going to split into teams. We're going to do everything collaboratively, the way that we do in Society for Improvement of Psychological Science, so that you'll get to experience the power of community, the power of meta-analysis, and the power of transparency and registry reports. So somewhere around December, I'll make the official announcement. If you're working on a meta-analysis or you're interested in a meta-analysis, come talk to me. I want to help you. If you want to do a meta-analysis with me, I have a bunch of topics and things that I've already started. You can join some of that. If you don't want to lead this, if you want to lead something on your own, we can discuss this further. If you have a meta-analysis and you want to improve transparency or you want to do things about publication bias, happy to help you with that. I've worked with a few of the faculty here and their students. So with you, with your PI, up to you completely. Just feel free to come talk to me about this. As you can see, I am working with a great team on templates. We have made some great progress. Last thing I'm going to say, 2 months ago, so this also started with a workshop in SIPS, we finally got the Open Science Framework to include our template. So now the Open Science Framework has a pre-registration template for a meta-analysis that we did with our team. So Kit from Chinese U, who was an MPhil student here, is also part of the collaborators. I think it's a big step because finally there's a way for you to do this simply. So you don't have to use my elaborate templates. You also have the template in the OSF, and you can go search for that. It's a lot more reasonable. It's not as long as detailed. You won't get lost. So it's meant for you to do things right in the Open Science Framework template. So we are working on things to become better. If you also want to help us make things better, because you have experience in meta-analysis, because you've done things, then everything that I just showed you is open for collaboration. You can be part of this. Okay? Good. So that's all for this week. We'll meet again next week. If you have any questions, find me on Slack, tag me.